Have you ever tried to watch everything at once? A single pair of human eyes cannot monitor every entrance, hallway, and perimeter of a building or a city simultaneously. These physical gaps create immediate vulnerabilities. Every blind spot is an opportunity for theft, accidents, or security breaches to go entirely unnoticed until it is too late. To fill those gaps, we developed closed-circuit television, or CCTV. It serves as an extension of our own vision, a technological solution dedicated to loss prevention and public safety. Public perception often stops at the camera itself, a weathered box bolted to a wall, passively recording to a local tape. That hardware is only the edge of the system. Modern security functions as an interconnected digital nervous system. To understand its reach, we have to follow the signal from the physical world all the way to the digital screen. The journey begins at the physical perimeter. The camera body, the lens, and the physical mount act as the primary collection point for environmental data. Security architects select specific focal length lenses and articulating mounts to manipulate the exact field of view, systematically eliminating physical blind spots. Capturing light data is only the first step. The challenge is moving that volume of information away from the lens into a centralized system. Legacy analog systems transmit this data as a continuous electrical waveform traveling down a traditional coaxial cable. Modern IP architecture digitizes the video, chopping it into discrete data packets that travel at high speeds over standard network cables. Hybrid systems act as a bridge, encoding signals from older analog cameras so they can join a modern digital network. Cameras are blind without these transmission arteries. The choice of cabling dictates the speed, scale, and overall intelligence of the entire security network. Once the signal navigates those arteries, it arrives at a storage hub, a DVR for analog feeds, or an NVR for IP-based systems. Many systems are now shifting to the cloud, replacing on-site recorders with decentralized remote servers. Storing thousands of hours of video creates a bottleneck at the interface. A massive archive is useless if a human professional cannot parse the footage. Tracking a subject through a facility used to be manual, requiring multiple operators and sprawling physical maps to identify which monitor matched which hallway. Modern control rooms solve this with video management software. A single operator can now search and filter thousands of high-definition feeds from one screen. The hardware captures and stores the data, but the VMS software transforms that raw video into searchable intelligence. From start to finish, the architecture is a single ecosystem. The camera, the network node, the server, and the software interface working in unison. Historically, CCTV was a passive tool, a way to check a tape after an incident had already occurred. Today, IP connectivity and cloud processing allow these systems to analyze feeds in real time, detecting anomalies and alerting operators before a threat escalates. The underlying objective remains unchanged: to safeguard entire city blocks, transit hubs, and private perimeters through a single, coordinated layer of security. Every camera is an active sensor, the physical terminal of an invisible, engineered fortress protecting our daily lives.